Hi everyone, I'm Omar. I'm an ML engineer at Hugging Face. Just to check, do people here know what Hugging Face is? Yeah? Oh, okay, most people. Yeah, so if you don't know, Hugging Face is an open source company. It's the creator of different open source Python libraries, such as transformers to access pre-trained models, or datasets to easily access and share datasets. It also has a hub, which is a platform in which anyone can share models, datasets and spaces. All of this is free and open source. And the talk of today will be focused on how to craft amazing machine learning demos, all with Python. So maybe in the last couple of weeks, you've seen lots of demos created, lots of screenshots of DALL-E Mini. For example, if you don't know what DALL-E Mini is, it's a system in which you write some text and it will generate some images. So these images are 100% generated. So for example, here the user wrote the Demogorgon from Stranger Things holding a basketball, and then it generates an image such as this. So this was an example of a nice demo that was created for DALL-E Mini, and in the last 2 months, so since June, we have been receiving over 5 million requests for new images every day. So it's quite wild how viral these demos can come. These were images I created just this morning. So the first one is a picture of minions visiting Yerevan, and the second one is a picture of minions visiting the Cascade complex in Yerevan. Again, like these are completely generated. It's not that there's a system or a database behind this. And the nice thing of these demos are that they are online, meaning that anyone can go and access them. So for example, here you can see a drawing that I made, and then I wrote a llama in the snow. And the picture at the right, it was completely generated by this one. So these are examples of nice interactive web demos that anyone can go and create and share. This is another demo. This one is called informative drawings. So here you can upload a picture and it will generate like the nice drawing kind of sketch style. This one is a bit more complex, but pretty much you can upload a picture of a person. It will generate a picture with the clothes and then the 3D object, which can have like very nice applications for the game industry, for example. So why is all of this interesting? So until a couple of years ago, and even today, when researchers want to share their research, they will have like these huge posters, and then they will publish the paper and maybe share it in Twitter or Reddit, something like that. What happens is that the ML research is not really that accessible. These are a couple of pictures we got from CVPR a couple of months ago. CVPR is a very large computer vision conference. And what researchers started to do is that they started to create these nice demos that anyone can go, anyone can try out in the computer source screen and see how these models work. So it's a much more interactive, direct way of showing people how your machine learning work actually works. So 3 years ago, it was very different. People were creating these huge spreadsheets. Most of the time, they were not sharing any code. If they were sharing any code, most likely they were not sharing any models or any datasets. And definitely, there were no demos at all. Nowadays, it's changing. There are much more demos, which is very, very exciting. So people share models, people share datasets, and people share spaces, which are the demos I will be talking today. So why demos? So the idea of the demos is that you can easily present a wider audience. So the people that can use your demo does not necessarily need to be ML engineers, right? They could be stakeholders at your company. If you're a freelancer, they could be a client. If you're at university, it could be for your school project. So that's one very nice aspect. The second aspect is reproducibility. So there's a thing in which many people just cherry pick the results and just show the nicest results. So by creating nice demos, you really allow anyone to just go and try out the demo and see how the model performs with your own data. And the third point is very interesting. It really allows a wider audience, a diverse user base, to identify and develop failure points. So for example, if you only have five white guys from the same company trying out the model, they will likely start to miss many edge cases, not edge cases, like they will not even try things because they didn't even think about it, right? So by having these demos, you really allow anyone to try this out. And not just ML engineers, again, like this could be from someone from social science, right? If you are creating a system that will impact certain population, you can really let the population try out the model before putting that in a real system in production. And this is an example of a quick interactive demo. So you upload a picture or click one of the examples, and then it will classify this as a alligator, American alligator. So we are at a turning point in usage of machine learning. So before it was only ML scientists, then maybe software engineers that could run a code app and could install libraries. Nowadays, anyone that has a browser, like you can go in your phone, you can go to this demo and you can try it out. So it's a very nice change of how machine learning is being shared. So let me show, let me tell you a quick story. So let's say that you want to create a model. So you spend 5 months in your company creating a model, and then you decide, okay, let me make an internal web app to show it to the rest of the company. And then when you start searching, you realize that you need to learn Flask, Docker, JavaScript, CSS, and a bunch of other tools. And then you will be saying like, okay, usually ML people don't like front-end technologies, so people get worried and scared, and they will run away. So it's actually much easier than it looks. So in the old ways, you would use different tools all across the stack. So if you train your model with TensorFlow, PyTorch, that's Python, right? Then you will create your containers with Docker, Flask, Amazon Web Services, Cloud. Then you will want to maybe store your examples. So if you want people to be able to flag, for example, worrying outputs of the model, you will want to store that in a database. And finally, you will need to write this nice web UI with HTML, JavaScript, and CSS. So all of these are different tools, and it's not very easy for someone from the ML world, right? So there are different open source Python libraries, such as Streamlit and Radio. Today I will be talking more about Radio. Radio is a very simple, minimalistic Python library that allows people to build very nice web demos and share them with the community in a very simple way. And I will show two other demos. So this first one is from Microsoft. Just to show that it's not limited just to images, you can also do things with audio. And here the idea is that the users can upload 2 different audio files, and you can do voice authentication, so you can identify if this is the same user speaking. And this is using a WaveLM, which was launched a couple of months ago. And as you can see at the right, it will tell you like how similar are the speaker voices. And the second one was using YoYoGAN, which is face stylization. So I put a picture of myself. I told the model that I want to be Disney style, and then that's the output for myself. It's not very nice. So maybe you're seeing this and you might be thinking like, okay, that looks too complex. I don't want to learn this. I will need to learn a bunch of new tools to do this. But really, Radio is a very minimalistic Python library. So there you can see like all the key components of it. So there are 3 key components. So you have the Radio interface, which is like the nice input-output kind of UI. It has the inputs. So in this example, the input will be an image, right? So users can upload an image. And the output will be a label in this scenario. So you will give a probability that this is an American alligator. And this line that is in orange, classified image, that's a function. That's any Python function. So this is extremely flexible because this could be TensorFlow, this could be PyTorch, this could be scikit-learn, this could be any library that you are using. So this is really a wrapper around your machine learning model, but this is extremely flexible to whatever your use case is. Then you just do app.launch, and you can have this locally in your terminal, you can have this in a code app, you can have this in a web UI. So this is very nice. It's really, really simple, so I'm going to show you like a very quick example. Is that a good size? Yes. So in this demo, I just have a text input, okay, a text output, and then the function, again, is any Python function that receives the input, which is text, and outputs something with the type of text. So in this case, it's just a hello world, so it's a classical like hello world scenario. So you receive a string, which is name, and you output hello. And then we have already this nice simple interface that you can write out direct, right? So if I write Omar, it will write hello Omar. Okay, so it's like very easy, simple UI, and you can really customize it much more. So as a second example, I'm using a library called transformers. Don't worry too much about the transformers specific code. Again, this can be any Python code that you want. But pretty much here, what I'm doing is loading a translation model from the Helsinki NLP lab from Helsinki. And this is a model that translates from English to Russian. This model comes from the Hugging Face Hub, so you can go to to the Hugging Face Hub. It has 60,000 open source free models. And the Helsinki NLP Lab in particular, they shared over 1,500 models to translate from one language to another. So you have many, many pairs, so from Spanish to English, from English to Russian, Russian to English, and all kinds of languages. So this pipeline from transformers allows you to pick whatever model you want. So in this case, I picked the English to Russian one. Here I have my prediction function. And then again, I have here like the nice simple interface. So the interface has a prediction function, so it's the same. It has an input. The input I specified again will be text, but now I want like a larger text box with 3 lines. And finally, the output will be text. Then you can customize a bit more the UI, so you can have like a nice title, a nice example. You can customize the CSS if you really want that. But pretty much the idea is always the same. So you have an input, you have an output, and you grab your machine learning model inference around that. So here is the inference of the model, in which I just execute the pipe with the text, and I retrieve the translation text. So that's the output I get from those, 10 lines of code. So I have here my title, interactive demo, Helsinki NLP English to Russian translation. Here at the bottom, I added a couple of examples. So you can click here, like this example from the bottom, and you can click submit, and you get the translation in Russian. I don't speak Russian, so I'm not sure if that's a good translation. I hope yes, but yes. What we found with researchers is that specifying examples, although it sounds very stupid and very simple, it really helps the users understand your model. Because if you have a demo that has as an input some medical kind of text, or if you have a transformer model for health-related data, they will not know that, right? Like any random user that goes to your model, to your demo, will not know that. So you can add some nice examples specific to your use case. So if your model is for protein-related stuff, you should add some protein facts to it. If your demo is about 3D objects, you can add some 3D objects as example for that. But yeah, that's pretty much how you can build a nice, simple demo. So okay, so you were able to build a demo, you were able to put that in a code lab or like put it in GitHub. But then how do you share it with the community, right? Like you're still expecting people to go to your GitHub repo or your code lab and execute code, and you would be surprised by how many people out there really don't understand code lab, and that's totally okay. Like they are not experts in code lab, they are not engineers necessarily, right? So how can you make like it extremely easy to just run any of these demos, right? Like DALL-E Mini is a very good example. DALL-E Mini was trending in Twitter, and the KFC account in Twitter was putting images from DALL-E Mini, and everyone was doing this kind of stuff, right? So how can you really make it so easy that like KFC can tweet about DALL-E Mini? So the idea is that you can also share these radio demos online for free with the rest of the community. And the platform where you can do it, if you don't want to host yourself, is called Spaces or Hugging Face Spaces. So Hugging Face Spaces is a Git-based repository system. So if you've used GitHub before, it's the same kind of workflow in which you can do git clone, git add, git commit, git push, or the same kind of things. And yeah, let me just very quickly show to you how you can do it. So I'm going to just click here, new space. I'm going to write Yerevan2. I will specify that I want to use radio, but again, you can use Streamlit, you can use HTML if you want to do that. You can use Flask and Fast API and other stuff. So you can, once you create it, this is a Git repository, so you can git clone and do all of your work locally, but right now, since this is a quick demo, I will just do everything here directly. So you just create a app.py file, and I will copy paste this code and commit my file. So this is exactly the same I had in my code lab. But the second part is that I also need to specify which are my dependencies, right? So in my case, it was transformers. I used PyTorch, and sentence is for the translation. So what will happen now is that it will take like 5 minutes to run, but it will build a Docker image under the hood, and after a couple of minutes, it will deploy something that will look like this. Okay, so this is exactly the same code. I didn't change anything. I just did it 10 minutes ago, so we don't wait. But this is the exact same demo that we were running in the code lab, right? You can click these examples, or you can write whatever you want here. And what is nice now is that this link is public. So right now, if you go to this link on your phone, you will land to this exact same demo. And now you can share this with your friends or your family, or if you're in a company, you can share this with your colleagues in your company. Okay? So 3 quick reasons, just trying to recap a bit what I just said to build an ML demo. The first one is for accessibility. Really allowing your research to get used by other people is extremely powerful. So if you are a researcher, either in academia or industry, you really don't know how powerful it can be to put your demo in the hands of many other people. Like, it really is very powerful. The second one is understanding the real-world limitations of your research, right? So if you only test your system with pictures of white men, or you only try with the queries or like the text that you can think of, you will for sure miss lots of scenarios. So this really allows people to try it out. And third, it's really easy. Like if you're doing research, the most likely you will have some code up, some running code in which you are already running your model. So just taking the extra step to build a demo and share it with the community is extremely easy. Now, if you don't want to share it with the community, right, if you have like health-related data, you can have private repositories, you can work in an organization with your team, but you can still create demos. So you are not limited to just share it with the community. It also allows people to collaborate within a team. There are many power features around spaces and radio, which doesn't make too much sense to dive right now. But just very quickly to show a couple of these. One is the advanced queue system, which allows the system to handle thousands of requests. So last week on Monday, there was the launch of Stable Diffusion. I don't know if you've read about that, but we launched a demo with this, and we have been getting a couple of thousands of requests per minute. We have generated, I think, 400,000 images every day since then, non-stop. And we've been able to do that thanks that Radio has a very nice queue that allows for this more viral kind of demos. The second one is organizations, which is what I just mentioned, that if you want to work in a team, you want many people to work in the same repo, it's just as in GitHub, the same kind of workflows, you can add people to the same organization. The third one is caching. So let's say that you have a demo in which creating, it does some protein-related stuff and it takes 2 minutes to run. Most likely, if you put that demo out there, people will get annoyed and they will just close the window because 2 minutes in the internet is a lot of time. So what Radio has is this nice feature in which it can cache a couple of examples, and that's very nice because then when people try the examples, which is maybe 80% of the time, the examples will be instantaneous, which gives a much nicer user experience. You can have GPUs as well. That's not out of the box, but that's something that you can also try to have. You can embed the spaces. That's very nice. So for example, if you are publishing in ECCP or CVPR, in those two conferences, it's very common to publish a website that has like a summary of the paper and some images. So what you can do with Radio is that you can embed the demo in your website or in your documentation. So for example, Cornea is a very famous computer vision library, and now they are embedding Radio demos directly in their documentation. So it's not limited to just the Hugging Face, it can be in your own website if you would like to. It is composable, and that means that you can really load any model or any space and connect one next to the other, so you can write some very interesting pipelines. Let's say that you find a model in English that creates, fantasy stories, like a GPT for fantasy stories, I don't know. But you would like to do that in Spanish, so you can pick a model that translates Spanish to English. Then you can go, so you can take that first model, then you can use the model that does the fantasy text generation, and then a model that will translate back from English to Spanish, right? Or if you have a model that will generate an image, but it's a low resolution image, and then you want to enhance the image to be higher quality, you can also do that. Or if you want to connect GPT with Stable Diffusion, so you use GPT to create some text, and then you use that text as an input for a image generation demos such as Stable Diffusion or DALL-E, you can do that kind of stuff. So we've seen very creative people doing very crazy fun demos as well. And finally, it has components for all kinds of things. So I've been showing you images and text and audio, but you have 3D objects, more complex audio files, you can output plots. So it's very, very flexible system, and at the same time, it's very minimalistic. This is a demo from Stable Diffusion, like I did the drawing at the left, like the spider and the all. Here I wrote all on a branch, and this was like a generated image. Here I wrote spider, and from my input, very bad drawing from a spider, now I have like, not great, but a better spider, I guess. And again, this is a link that anyone can go. So it's like a very powerful concept. And as nice benefits of doing this, one I mentioned before is that you can showcase to stakeholders, but the other is that you can build your own portfolio of ML demos. So if you're, especially if you're a student, every time you're doing a research or a school project, most likely it will end up being lost in your own GitHub or like in a Google Drive link. But instead, you take this extra step of creating a nice UI that anyone can go to and try it out. After 1-2 years, you will have like a nice collection of like all of your ML projects from university, which is very, very nice, and I think that can also enhance like job opportunities. So cool, yeah, that was pretty much everything I wanted to show today. Thanks a lot.
We have a couple of minutes for questions. So please. Yeah.
Does having cases have any support limitations, or your like records can be as big as you want?
Yeah, that's a good question. So it does have some limitations. So right now it's just running in CPU by default with 16 gigabytes of RAM. So it's still like good specs, but it's not amazing specs. We've seen that some people want to run spaces with GPUs when they want like very fast inference. And what we do nowadays is that we provide free GPUs to community members. So people that are using open source work or doing cool work, we will provide free GPUs, and more for companies that want to have like, I don't know, 30 GPUs running at the same time. For them, it's more of a paid service. But that usually the limitations it has are very friendly. Like I think 99% of the use cases have like can be met with the free storage. Sure.
Thanks for the great show. So I was wondering whether these demos are sometimes used also for collecting more data, like saving the queries on the system.
Yeah, that's a great question. I think a good example of this is this project from one intern. So his name is Chris. He's from a community called Masakane. Masakane is a community focusing low resource languages in Africa. And he has built this nice demo. My internet is a bit slow, so it will take a bit to load. But what he's doing is creating a data set of speech, so people saying digits, so 1, 2, 3, 4, up to 10, up to 20 actually, in different African languages. So there are over 1,000 African languages. And he has created a demo which has the idea of being a crowdsourced data set owned by the community. So it can be used, of course, with acknowledgement of the members and the right purpose, right? So that's something that people have been exploring. And there are some tools that will allow you to automatically save your data from the space to a data set. So that's also like a very nice addition. So radio has like a callback, let's say, that when you click a button that says flag, it will save the input and output to the data set. But that's with like the user actually clicking the flag, so it's with acknowledgement from the user. Yeah. But again, like all of the coding radio, like the inference function is any Python code, so you have lots of flexibility to define how you want things to be.
Yeah, so you mentioned that Hugging Face Spaces also accepts Streamlit, but you can remember, I know this one you prefer, right, radio over Streamlit. So.
Yeah. So I'm a bit biased because we acquired radio a couple of months ago, like 1 year ago, so in November. But we do support both Streamlit and radio. My experience, like being very, very objective, is that they really serve different purposes. So radio is very, very nice in the sense that the code is minimalistic and very easy to understand. So if you have interfaces which are very clearly input-output, or a collection of interfaces in which all of them are input-output, radio really shines. It's like extremely easy. Once you want more complexity, like significantly more complexity involved in your demo. Streamlit tends to have more components for your use cases. Streamlit has a very nice community in which the community are contributing like their own components. And because of that, you can find like there's a component for molecules, for example. So if you want like some very, very nice molecule visualization, you would need to compare which components are existing, but Streamlit has a bit more of these community contributed components. So it has its pros and cons. Both are relatively simple. Creative is a bit more simple, like if you are just learning and you want something quickly, especially for model demos, it's very nice. If you want complex data visualizations, usually Streamlit is a bit nicer.
Awesome.
Yeah. Anyone wants any stickers? There are many stickers here as well. Stickers.
Thank you.